So we're going to be talking about Chapter 12. This is page 166 in your chemistry books. And first thing I'd like for you to do is to kind of go down to this part in your book because it reviews the key points that you learned in Chapter 3. So go ahead and pause the video and read over these bullet points. Okay, so first we're going to talk about kind of the big picture. There's over 100 elements, and the key difference between them is the number of protons they have. So each element is completely unique in that it has its own number of protons. So for instance, as it says here, lithium has 3 protons, beryllium has 4. You're never going to have an element that doubles up on that. You're never going to have an element that has 5 and another element that has 5. And just as a reminder, especially like on this table, they're not always going to mark which number is the proton. It's always going to be the lowest one. And just as a reminder, the number of protons is also the same as the number of electrons. So if you were to have a question, let's say about carbon, and it said how many protons does carbon have, how many electrons does carbon have, the number would be the same. You would say it had 6 protons and 6 electrons. Also, the number of electrons, which is the number of protons, and the number of the outer shell electrons dictates an element's chemical behavior. So I don't know if it mentioned it here, but a little bit farther down we're going to be talking about why the elements are in this order, and a lot of it has to do with kind of how the elements act or behave. And one of the most important points of that is the electrons. You might also notice that the periodic table shows the elements in order of increasing proton number. So, we start with hydrogen, and then we get to helium, and then it kind of bumps over here, 3, 4, 5, 6, 7, 8. So you'll notice that as we go across our periodic table, the number of protons increases by 1. Also, we can also mark at this zigzag line, this is separating the metals from the nonmetals. And an element being a metal or a nonmetal also kind of has to do with how they react or behave. So now I'd like for you to scroll down to where it says more about the groups. And I'd like for you to read these 4 bullet points. And so pause the video, read those 4 bullet points, and then we'll continue. So the biggest thing about the groups is that the groups are organizing the elements, again, because of how they react or don't react. The group number at the top is the same. So this group number here, and we kind of skip this part right here. So don't worry about this right now, the transition elements. So the group 1, 2, 3, 4, and we're talking the up and down, the columns. This number indicates how many valence electrons there are. So, for instance, I'm going to try my best to draw for you. I don't know how much you guys know about this, but if we were to draw an element, we would give it a really rough drawing. Remember, these things move quick. There's no real accurate way to draw them, so a lot of people just draw them like this. So let's say we were talking about, let's just pick one. Let's do boron. So if we do boron as 5 protons, so this is boron. Oh, great handwriting. Boron. Should have just done the symbol. Okay, and so if we go back to our periodic, boron had 5. Okay, and so 5 protons, and a lot of times, so I think we said 5 protons, which also means that we have 5 electrons, regular electrons. Electrons and valence electrons are not the same thing. We're going to talk about what they are. Okay, So if we look at, we always draw these rings, and these rings have a rule to them. The first ring, which would be closest to the nucleus in here, would be the nucleus of the element, or the atom. So that's the nucleus. And then outside of the nucleus, and the nucleus is where your protons are, and your neutrons. I don't know how much you guys have talked about neutrons. And so your electrons have to go somewhere. And so your electrons go on these rings. And these rings have rules, as I mentioned. And the rule is that they can only hold so many electrons. So this first ring can actually only hold 2 electrons. And the second ring can hold 8. And then if we were to have a third ring, it could hold 8. And for our purposes right now, we're only going to go up to the second ring because boron only has 5 electrons. So we're not going to need to go up to the third ring, and I'll show you why. So I'm going to make these green. So if we were to draw these electrons, we would start on this inner ring, and we could put that 1 is here, 1 of the 5, 1, 2, and now that ring's full, but we still have 3 more. So the third one's going to go here, 3, 4, and then I'm just going to go over here for the 5th one. And there's 5. Now, if we look back, it said it was in group 3. So again, we're doing boron. It says it was in group 3. And our text says that this group number is the number of valence electrons. And I'm sorry if you already know all of this, but in case you don't, valence electrons is not talking about the total of electrons. It's talking about whatever electrons are on the outermost shell or ring. These are called shells. And so, I don't know if you need to know that, but I'm going to keep saying it because I'm just classically conditioned to do so. So, whatever, like we didn't use this last shell, this third shell, we didn't use that one. So we're just going to look at the last shell that we used, and however many electrons were on that last shell is where we get that group number. So we have 1, 2, 3, and the fact that we have 3 is how many valence electrons we have. Okay. Oops. You get the idea. So that's where that group number comes from. Now again, remember we said this one can hold up to 8. Okay? So one thing we should think about is the more full the ring is, the more stable the element is. So think about when you're hungry. When you're hungry, you're not full, and you tend to be hangry. If you've ever heard about that, hangry. You're not happy. So you tend to react more to things. You tend to get mad easily, things like that, because you're not full. So look here at boron. It could have up to 8. It's hungry. It's not full. So boron is going to be a reactive element. How reactive? We'll talk about that later. Now if it were full, not hungry, think about when you're full, not hungry, you tend to be pretty happy. Non-reactive. You tend to let things go, laid back. So that's kind of a way that I always tell my students to remember. So let's talk about this last column of elements. So I think your text mentioned that. Yes, the atoms of the group 0 elements have a very stable arrangement of electrons in their outer shells. This makes them unreactive. So let's talk about that right here. So let's talk about helium. Helium, oh, and also, fun fact, this chart is giving them a group number of 0, which to me is interesting. This one was 7. Sometimes you'll see this marked as a group number 8, and we'll talk about why. But we'll go with 0, and that's fine too. So let's talk about helium. So I'm going to erase. Oops. Okay, so helium has 2 protons. Remember, we used the smallest number. And if it has 2 protons, this is helium. Look, I'm using the symbol. I'm learning from my mistakes. Okay, so if it has 2 protons, that means it also has 2 electrons. And if you'll remember here's our nucleus. We can only fit 2 electrons on that first shell. So if we only have 2 electrons to begin with, that means that that first shell, and only shell that we need, is full. And if the shell is full, the element is unreactive. Okay, so let's talk about another one. Let's talk about neon. Oops. So neon, Ne, 10 protons. So this is neon. And we've got 10 protons, which also means we have 10 electrons. I always like to write them out. The more practice, the more you'll remember. Okay, oops. And so let's go ahead and start putting them on there. Here's our nucleus. So we start with the first shell, and it can only hold up to 2. And the second one can hold up to 8. And we know we have more than 2 electrons, so we are going to use that second shell. So let's start placing them. We have 1, 2, 8 are left, and we have 8 spots. So 2, 3, 4, 5, 6, 7, 8. Well, that last shell can hold 8. Remember, that's the one we look at when we're figuring out our valence electrons. So that means how many valence electrons are there? There are 8. And since that shell can hold 8, again, it is full and unreactive. And you'll see that for all of these in this column, this group, all of them except for helium are going to have 8 valence electrons. If we were to do this little circle drawing, again, for all of these, they would all have 8 except for helium, which is also why sometimes this is group 8. But what's important to remember is that's why these are unreactive elements, is because they are full. So knowing that information about valence electrons and knowing about, reactivity, let's chemists predict the properties of elements and how they're going to react with each other. So we talked more about the groups. Let's go down to where it says more about periods and the metals and nonmetals. So I'd like for you to read those 2 sections to yourself first, and then we're going to talk about them. So go ahead and pause the video. So let's talk about the periods, and the periods are the rows. So if we go back to our periodic table, so period 1 is hydrogen, and then period 2 would include everything here. Oh, and period 1 also includes helium. Then period 2 is here, period 3, and so if we think back to when we were doing our shells, The periods are helpful because